People often imagine life in space as a solved problem. We already went there. We already built stations. So living there must just be a matter of scaling things up. Movies make it look calm and clean. Wide windows, slow movement, quiet routines. Space feels like a place where humans simply continue living, just with better views. That image is comforting. And it's also misleading, because space does not slowly become easier once you arrive. It becomes harder the longer you stay. The first days in space feel exciting. Astronauts talk about wonder, floating freely, seeing Earth from above. But that feeling fades faster than people expect. After the excitement passes, the environment does not change. Gravity is still missing. Radiation is still present. Systems still demand constant attention. Life in space is not about doing amazing things. It is about preventing bad things from happening every hour, every day, without pause. On Earth, life is supported by the planet itself. Air flows freely. Gravity does its job. The environment absorbs mistakes without asking permission. In space, nothing supports you unless you build it. Air must be created. Pressure must be maintained. Temperature must be controlled without failure. This changes how everyday life feels. Breathing becomes something you depend on machines for, not something your body does naturally. Eating changes too. Fluids float. Smells linger. Crumbs become hazards. Even simple meals require planning and constant cleanup. Sleeping sounds easy, but it isn't. Without gravity, the body struggles to rest properly. Light cycles confuse the brain, and sleep quality often drops. Astronauts talk about always being aware of where they are. There is no true background comfort. The environment never fades from attention. Plait has often pointed out that space is not dangerous because it explodes. It is dangerous because it quietly removes everything humans rely on. Nothing in space tries to help you recover. If you feel tired, space does not slow down. If you feel sick, space does not adjust. Even when all systems work perfectly, the body still pays a price. Bones weaken, muscles shrink. Vision can change over time. These effects do not stop just because people understand them better. Knowing what happens does not prevent it from happening. Exercise helps, but it does not replace gravity. Shielding helps, but it does not remove radiation completely. Living in space means constantly compensating for what Earth gives us for free without ever reaching balance. This makes long-term life very different from short missions. Short visits accept damage because recovery happens back on Earth. Long stays do not have that option. Damage accumulates, and recovery becomes slower and more uncertain with time. This is where the idea of space colonies starts to break down. Colonies suggest comfort, growth, and stability. Space offers none of those naturally. Everything must be forced into place and kept there with effort. The longer humans stay, the more their lives revolve around maintenance rather than exploration. This is not a failure of technology or courage. It is a result of physics and biology interacting without compromise. Space does not adapt to humans. Humans adapt temporarily to space, and that difference matters more than people realize. Understanding this does not make space less fascinating. It makes it more honest. Because once the illusion fades, the real story of living in space becomes far more complex than the dream. One of the biggest confusions about space is that people mix up two very different ideas: surviving somewhere and actually living there. These words sound similar, but in space they mean completely different things. And misunderstanding this difference creates unrealistic expectations about the future. Survival means keeping a human alive for a limited period under controlled conditions. Living means maintaining health, stability, and normal biological function over long periods without constant damage quietly building up in the background. Space missions are designed for the first, not the second. The International Space Station is often used as evidence that humans can live in space. In reality, it proves something much more specific. It shows that humans can survive in orbit for months while carefully managing decline, knowing that recovery will happen later on Earth. Astronauts on the ISS are not expected to remain perfectly healthy. Bone loss, muscle weakening, and changes in vision are accepted because the mission has an endpoint. The body is allowed to take damage because gravity, rehabilitation, and medical care await back home. This mindset changes everything. Space becomes a place you temporarily tolerate, not a place you settle into. No one aboard the station expects their body to adapt permanently to microgravity. The goal is always to endure, complete the mission, and return. Plait has often explained that the ISS should be thought of as a laboratory, not a prototype city. It exists to study how humans break down in space, not how they flourish there. That distinction is critical, but often ignored in popular discussions. A useful comparison is Antarctica. Humans can stay there for long periods using advanced technology, strict routines, and careful planning. But even Antarctica, harsh as it is, still provides gravity, breathable air, and familiar radiation levels. Despite that, Antarctic bases are rotated regularly. Crews come and go. No one argues that Antarctica is becoming a natural place for large permanent populations. It is a place humans can survive temporarily, not a place designed for normal life. Submarines offer another comparison. Crews live for months underwater in sealed environments, relying entirely on machines for air and survival. But submarines are missions, not settlements. They are designed around endurance, not comfort or growth. Space habitats would face challenges far beyond both examples. There is no gravity to stabilize the body. Radiation levels are much higher. Isolation is more extreme. And help is not just far away. It is unreachable in real time. In space, the wall around you is not just shelter. It is the only thing separating you from vacuum, radiation, and temperature extremes. That reality never fades into the background, no matter how long you stay. Living under constant dependence on machines changes psychology. The environment never becomes passive. Every sound, reading, and system status matters. There is no moment when space allows you to forget where you are. On Earth, nature absorbs small failures. In space, there is no such buffer. Stress does not dissipate outward. It accumulates inward, affecting systems, people, and decision-making over time. This is why long-term space living is not just an engineering problem. It is a biological and psychological challenge layered on top of physical limits. Technology can slow damage, but it cannot remove the mismatch entirely. Surviving in space is an extraordinary achievement. Truly living there, without constant decline, remains an unsolved problem. And that gap is much larger than most optimistic visions are willing to admit. One of the most persistent beliefs about humans in space is that the body will eventually get used to it. That if astronauts stay long enough, their biology will slowly adapt and the problems will fade. This idea sounds reasonable, but decades of spaceflight data show something very different. Adaptation does happen in space, but not in the way people imagine. The body does not become better suited for space. Instead, it learns how to function while slowly losing abilities that are essential on Earth. That difference is subtle, but extremely important. Take bones as an example. On Earth, bones constantly rebuild themselves in response to stress from gravity and movement. In space, that stress is removed, The body responds by reducing bone density because it no longer sees a reason to maintain it. This process does not stop after a few weeks. Measurements from long-duration missions show that bone loss continues over time. Exercise slows it down, but it does not fully stop it. The body is not adapting to space. It is adapting away from Earth. Muscles follow the same pattern. Without gravity, muscles used for posture and movement weaken because they are no longer needed in the same way. Astronauts exercise for hours every day just to limit this effect, not eliminate it. Even with constant training, muscle loss still occurs. This tells us something important. The body is not learning to thrive in space. It is being actively prevented from declining too quickly through artificial effort. Vision changes provide another clear example. Many astronauts experience changes in eyesight during long missions. Fluids shift toward the head in microgravity, altering pressure inside the skull and affecting the eyes. These changes are not psychological. They are physical and measurable. In some cases, vision does not fully return to its original state after astronauts come back to Earth. Experience does not protect against this effect. Plait has often emphasized that space reveals how tightly human biology is tied to Earth conditions. Gravity is not optional input. It is a constant signal that shapes how our bodies organize themselves from the inside out. The immune system also behaves differently in space. Studies have shown changes in immune response, including the reactivation of dormant viruses. This is not because astronauts are unhealthy, but because the body is operating outside familiar conditions. Again, these effects do not disappear with experience. Veteran astronauts do not become immune to space-related biological changes. The same patterns appear again and again across different missions and individuals. What makes this especially important is time. Short missions hide these problems because recovery happens later. Long missions reveal them clearly because the body does not reach a stable new equilibrium. Instead of adapting toward health, the body adapts toward efficiency and microgravity, often at the expense of strength, density, and resilience. That trade-off only makes sense while the person remains in space. Once back on Earth, that adaptation becomes a disadvantage. Rehabilitation is required because the body has reorganized itself around a different set of assumptions about how it needs to function. This is why space agencies never treat space as a permanent biological environment. Every mission is planned with return in mind. Spaceflight is not a new baseline. It is a temporary condition. The idea that humans will eventually evolve to live comfortably in space misunderstands the timescales involved. Evolution operates over many thousands of generations, not within individual lifetimes or mission schedules. This is not pessimism. It is what the data shows. Space does not train the body to belong there. It slowly reminds us where we actually come from. When people think about space stress, they usually imagine fear during launch or danger during spacewalks. In reality, those moments are brief. The harder psychological challenge comes from long periods where nothing dramatic happens, but pressure never fully disappears. Astronauts are carefully selected, trained, and prepared for isolation better than almost anyone on Earth. Even so, long missions consistently show that the human mind does not simply relax into space life over time. Life aboard a space station is extremely repetitive. The same modules, the same routines, the same people, and the same environment day after day. There is no real change of scenery and no true separation between work and rest. On Earth, monotony is softened by nature, movement, and choice. In space, the environment is sealed and controlled. You cannot step outside for air, silence, or distance from others. That limitation matters more than people expect. Plait has often pointed out that humans evolved in large, open environments, filled with variation. Our brains are tuned to constant change, social flexibility, and physical movement across real landscapes. Space removes most of that input. The sensory world becomes narrow and artificial. Sounds come from machines. Views are limited. Even Earth, when visible, is distant and unreachable. This does not cause immediate breakdown. Instead, it creates slow psychological strain. Small irritations feel larger. Minor disagreements linger longer. Motivation fluctuates more sharply than it would on Earth. Sleep is another major factor. On the International Space Station, astronauts experience many sunrises and sunsets each day. Artificial schedules try to compensate, but the brain does not always cooperate. Poor sleep affects attention, emotional control, and decision-making. In an environment where precision matters, even small cognitive changes can increase stress and workload over time. Isolation also changes how people relate to risk. Astronauts know that serious emergencies cannot be solved by calling for help. That knowledge sits quietly in the background of every task. Even when everything works, the awareness that failure would be unforgiving never fully disappears. Space does not allow mental distance from consequences. That constant awareness is mentally expensive. Studies from space missions and Earth-based isolation experiments show similar patterns. Over time, people become more inward-focused, less patient, and more sensitive to social tension. These effects are not signs of weakness. They appear in highly trained professionals operating under extreme conditions. The mind is responding exactly as it evolved to respond. What matters is that experience does not eliminate these pressures. Veteran astronauts still face them. Familiarity improves confidence, but it does not make isolation feel natural. This is why space agencies limit mission length and carefully manage crew dynamics. The goal is not to eliminate stress, but to prevent it from accumulating beyond control. Long-term space living would amplify these challenges, not solve them. More time does not mean more comfort. It means more exposure to conditions the human mind did not evolve for. Space does not break people suddenly. It wears them down quietly through repetition, confinement, and constant awareness of risk. Understanding this makes the challenge of living in space clearer. It is not just about keeping bodies alive. It is about keeping minds stable in an environment that never truly relaxes. When people imagine daily life in space, they often assume that routines eventually become automatic. That after enough time, checking systems, maintaining equipment, and monitoring safety will feel normal and effortless. In reality, life support in space never fades into the background the way it does on Earth. On Earth, survival systems are mostly invisible. Air flows naturally. Water arrives without effort. Temperature stays within safe limits most of the time. When something breaks, there is usually time, redundancy, and outside help. Space removes all of that at once. In space, every basic need depends on machines that must work continuously. Oxygen must be generated or stored. Carbon dioxide must be removed. Water must be recycled again and again with extreme efficiency. None of this can pause, even briefly. This means daily life is built around monitoring rather than living. Astronauts are not just explorers or scientists. They are caretakers of the systems that keep them alive. Checking readings, cleaning filters, and responding to alerts is part of normal life. Plait has often emphasized that space is not dangerous because systems fail often, but because they are never allowed to fail at all. A small delay on Earth is inconvenient. The same delay in space can become serious very quickly. Temperature control shows this clearly. In orbit, one side of a spacecraft can be exposed to intense sunlight, while the other faces extreme cold. Without constant regulation, temperatures would swing far beyond what the human body can tolerate. Fire behaves differently as well. In microgravity, flames spread in unexpected ways and consume oxygen more evenly. This is why fire safety in space is taken extremely seriously, even though actual fires are rare. The important part is not how often things go wrong, but how much attention is required to keep them from going wrong. Space does not allow casual neglect. Systems demand awareness at all times. This creates a form of mental load that never fully disappears. Even during rest periods, astronauts know that their environment exists only because machines are functioning correctly. Over time, this changes how people experience comfort. On Earth, comfort often comes from forgetting about infrastructure. In space, comfort comes from constant confirmation that infrastructure is still working. Long-term living would amplify this effect. The longer people stay, the more maintenance is required. Components wear down, filters clog, sensors drift. Every repair must be planned carefully because mistakes are costly. Unlike Earth, there is no surrounding environment to absorb wear and tear. Everything happens inside a closed loop. Waste does not disappear. Heat does not escape naturally. Problems remain inside the system until humans address them. This is why space habitats are often compared to life support machines rather than homes. Homes exist within forgiving environments. Space habitats must actively fight their surroundings every second. The idea that space living will eventually feel normal misunderstands this relationship. Normal life relies on stability and forgiveness. Space provides neither without constant effort. Technology can make systems more reliable, but reliability does not equal relaxation. Even perfectly functioning systems require monitoring because failure is not an option. This is one of the reasons long-term space living remains so difficult. Life becomes centered around preservation rather than growth. The environment never steps back and lets people simply exist. Living in space is not about mastering comfort. It is about maintaining a fragile balance that never truly settles into ease. When people talk about space settlements, the picture often starts small and then grows naturally. A few people arrive, then more follow, and eventually a community forms. On Earth, that pattern makes sense. In space, it quietly breaks down as soon as numbers increase. Supporting a small crew in space is already one of the hardest engineering tasks humans attempt. Every person needs air, water, food, space, and protection. Adding more people does not just multiply these needs. It changes how the entire system behaves. In closed environments, complexity grows faster than population. More people mean more interactions, more waste, more heat, and more stress on systems that already operate near their limits. Space does not provide extra room for inefficiency. On Earth, cities work because they sit inside massive natural systems. Air circulates freely. Water cycles naturally. Waste can be diluted, processed, or dispersed over large areas. Space offers no such support. Everything stays inside. This means scaling up requires perfectly balanced systems that never drift far from optimal performance. Even small deviations become dangerous when there is no outside environment to absorb mistakes or smooth out fluctuations. Plait has often pointed out that people underestimate how much Earth does for us silently. When that support disappears, every problem becomes sharper. In space, growth does not make life easier. It usually makes it more fragile. Food production shows this clearly. Growing food in space is possible, but it requires energy, water, light, and constant monitoring. A small experiment can be controlled carefully. Feeding many people multiplies risks and resource demands. The same applies to waste. On Earth, waste is managed by ecosystems and infrastructures spread over large areas. In space, waste must be recycled almost perfectly. Any imbalance stays trapped in the system and affects everyone. Social dynamics also change with scale. In small crews, conflicts can be managed closely. In larger groups, tensions become harder to resolve, especially when there is no physical escape or change of environment. On Earth, people cope with stress by moving, changing surroundings, or separating from conflict. In space, movement is limited and surroundings remain the same. Scale does not create freedom. It often increases pressure. Another overlooked factor is failure recovery. Small crews can sometimes adapt quickly to emergencies. Larger populations depend more heavily on stable systems. When those systems fail, consequences affect many people at once. This creates a paradox. The more people you add to make a space settlement feel normal, the more demanding and unstable the system becomes. Normal life relies on resilience. Space systems tend toward brittleness. Long-term settlements would also require continuous resupply or extremely advanced recycling. Both options tie the settlement tightly to complex logistics that must never fail for long periods. On Earth, societies survive disruptions because resources and support are distributed. In space, everything depends on a narrow chain of functioning systems. Breaking that chain, even briefly, can have serious consequences. This is why most realistic space plans remain cautious about scale. They focus on small numbers, clear goals, and limited duration. Expansion sounds hopeful, but physics makes it expensive and risky. The difficulty is not imagination. It is that space does not reward growth the way Earth does. It rewards control, precision, and limitation. As numbers increase, living in space becomes less like building a city and more like maintaining a fragile machine that cannot afford surprises. After hearing all of this, it's easy to think the story of living in space is pessimistic. Radiation, weak gravity, isolation, fragile systems, scaling problems. It can sound like a long list of reasons not to try. But that reaction misses an important point about what space exploration is actually for. Space was never meant to be comfortable, and it was never meant to replace Earth. The mistake happens when people quietly shift the goal from exploration to habitation, without realizing how different those goals really are. Exploration accepts limits. Permanent living tries to erase them. Plait has often explained that space exploration works best when it is honest about what space is. It is an extreme environment that teaches us through resistance, not through accommodation. Space does not welcome us, but it does teach us very clearly. One of the most valuable things space gives us is perspective. Seeing Earth from orbit reveals how thin and fragile our living zone really is. A narrow layer of atmosphere, a magnetic field that quietly protects everything. Conditions that look ordinary only because we have never lived without them. When astronauts describe this view, they rarely talk about escape or expansion. They talk about appreciation. Space does not make Earth feel small. It makes it feel precious. That emotional response is grounded in physical reality, not poetry. This is why many scientists argue that the future of space exploration is not about moving humanity away from Earth. It is about understanding Earth better by studying it from outside. Satellites that monitor climate, oceans, and weather already save lives and resources. Space also forces technological clarity. When systems must work perfectly, inefficiencies become obvious. Water recycling, energy management, medical monitoring, and materials science improve because failure is not tolerated in orbit. These improvements do not stay in space. They return to Earth and quietly make life more resilient here. In that sense, space exploration is not an escape plan. It is a feedback loop that strengthens our ability to live where we already belong. Living in space long-term remains hard because it conflicts with how humans evolved. That does not mean space exploration is a mistake. It means it must remain focused, limited, and honest about its costs. The danger comes when stories promise comfort where none exists. When they suggest that living off Earth will somehow be easier than fixing problems on Earth. Space does not offer shortcuts around responsibility. Every attempt to live in space reminds us of the same lesson. Life is not guaranteed by technology alone. It is supported by environments that took billions of years to stabilize. Earth is one of those rare environments. Understanding why living in space is harder than we admit does not close doors. It clarifies which doors are real. It separates ambition from illusion and replaces fantasy with informed choice. The universe is vast, but it is not generous. Most of it is empty, cold, and hostile to complex life. Earth is not typical. It is exceptional, and space exploration keeps proving that, again and again. When we stop pretending space will eventually feel like home, we can finally appreciate what it truly offers. Knowledge, perspective, and humility. Not comfort, not safety, and not replacement. Living in space is harder than we admit because living itself depends on conditions we rarely notice. Space strips those conditions away and shows us, without exaggeration, what really matters. There is one more reason why living in space is harder than we admit, and it is less obvious than radiation or gravity. It is the simple fact that space does not allow mistakes to fade away. On Earth, time often fixes problems. In space, time usually makes them worse. On Earth, a small error can be corrected gradually. A delayed repair, a flawed design, or a bad decision can often be compensated for by the environment itself. Air, gravity, and ecosystems quietly help absorb the consequences. Space provides no such support. In space, problems rarely disappear on their own. A minor inefficiency in a system slowly becomes a serious issue. A tiny leak grows. A sensor drifts out of calibration. Materials degrade under radiation and temperature cycles without rest. This creates a world where everything has a lifespan that must be tracked carefully. Nothing can simply be forgotten. Every component must be monitored, replaced, or repaired before it fails, because failure rarely stays isolated. Plait has often pointed out that space is honest in a way Earth is not. It does not hide consequences behind comfort. If something is flawed, space exposes it directly. That honesty is useful, but it is also exhausting. Living in such an environment means constantly planning ahead. Supplies must arrive on time. Systems must be serviced before they show obvious signs of trouble. There is little room for improvisation or delay. This forward pressure affects how life feels day to day. People are not just living in the present. They are always thinking several steps ahead, anticipating what could go wrong and how to prevent it. On Earth, long-term planning is balanced by moments of rest and forgetting. In space, forgetting can be dangerous. Attention becomes a survival skill rather than a choice. This also changes how people relate to time. Days feel structured and tight. Weeks feel repetitive. Months feel heavy, because the environment does not evolve or soften with familiarity. Even celebrations and milestones feel different. They happen inside the same walls, under the same artificial conditions, with the same systems humming in the background. The setting never adapts to the moment. Over long periods, this constant awareness reshapes priorities. Comfort becomes secondary to stability. Creativity gives way to caution. Growth is limited by the need to preserve balance. This does not mean humans cannot find meaning in space. Astronauts often speak about purpose, teamwork, and focus. But that meaning comes from mission and discipline, not from ease. A place where living depends on constant vigilance can never fully become home. Home is where attention can relax, where mistakes are survivable, and where life can unfold without continuous control. Space denies that by its nature. It demands control at all times, and it never rewards neglect, even briefly. This is why long-term visions of everyday life in space often feel incomplete. They show the setting, but not the pressure. They show the technology, but not the mental cost of maintaining it. Understanding this does not diminish space exploration. It deepens it. It replaces simplified dreams with respect for reality and replaces comfort with purpose. Living in space is harder than we admit because life itself depends on forgiveness, and space is not forgiving. Whenever the conversation about living in space starts to feel uncomfortable, someone usually says the same thing. Technology will fix it. Better shielding, artificial gravity, smarter systems. The problems are real, but they are temporary. This idea sounds reassuring, and that is exactly why it is dangerous. Technology absolutely helps in space. Without it, humans would not survive there at all. But helping and solving are not the same thing. Technology reduces damage. It does not remove the underlying conflict between human biology and the space environment. Radiation is a clear example. Better materials and thicker walls can reduce exposure, but they cannot eliminate it completely without adding enormous mass. Mass increases launch difficulty, fuel needs, and risk. Physics does not offer a free upgrade. Artificial gravity is another popular idea. Spinning habitats sound elegant on paper, but they introduce new problems. Rotation creates uneven gravity, complex engineering stresses, and motion sickness. No large rotating habitat has ever been tested with humans long-term. Plait has often warned that ideas sounding simple in theory become extremely complex when scaled to real human lives. Space is full of concepts that work beautifully on diagrams but struggle in reality. Life support systems follow the same pattern. Recycling air and water works, but only with constant monitoring, maintenance, and replacement. These systems do not become self-sustaining just because they exist longer. On Earth, ecosystems balance themselves over time. In space, balance must be actively enforced. Technology does not relax. It demands attention forever. A system that works today still needs care tomorrow. Another misunderstanding is that future technology will somehow make space feel normal. But comfort is not a technical feature. Comfort comes from forgiveness, and space does not forgive. If a system on Earth degrades slowly, the environment often absorbs the problem. In space, slow degradation is often worse than sudden failure, because it hides danger until margins disappear. Technology also adds complexity. More advanced systems mean more interactions, more dependencies, and more failure points. Reliability improves, but brittleness increases. Space punishes brittle systems. This is why space engineers are conservative. They prefer proven solutions over elegant ideas. They understand that novelty increases uncertainty, and uncertainty is expensive in space. The belief that technology will eventually remove all limits misunderstands how progress actually works. Progress shifts limits. It does not erase them. Each improvement reveals a new constraint underneath. Human biology has not changed in thousands of years. Cells still divide the same way. Bones still respond to stress. Radiation still damages DNA. Technology works around these facts, not through them. The longer humans stay in space, the more technology is required just to maintain baseline health. That creates a loop where survival depends on increasing system complexity over time. This is not a sustainable pattern without constant input, resources, and attention. Space does not allow systems to settle into simplicity. It pushes them toward continuous management. The dream that space will become easier as technology improves ignores one crucial truth. Space does not get easier. We just get better at holding the line for a while longer. That distinction matters, because it changes expectations from permanent living to managed exposure, from homes to habitats, from settlement to occupation. Technology is powerful, but it is not magic. It does not turn hostile environments into friendly ones. It only builds temporary islands of safety inside them. Living in space is harder than we admit because we keep expecting tools to change reality, instead of accepting that reality sets the rules. At some point, every serious discussion about living in space runs into a subject people don't like to talk about for long. Not physics, not biology, time, money, and logistics. These are not exciting topics, but they decide what is possible far more often than imagination does. On Earth, distance is inconvenient. In space, distance is transformative. Every kilometer adds delay, risk, and cost. Supplying humans in orbit already requires constant launches, careful timing, and international coordination on a scale few industries ever attempt. The International Space Station works because it is close enough to Earth to be rescued, resupplied, and repaired. Even then, it depends on a steady flow of cargo missions just to maintain basic operation. Moving farther away changes everything. A mission to the Moon is manageable because help is days away. A mission to Mars pushes that delay to months. Communication becomes slow. Rescue becomes impossible. Resupply becomes rare and extremely expensive. Plait has often explained that space logistics are unforgiving because there is no margin for improvisation. If you forget something on Earth, you buy it. In space, forgetting something can define the entire mission. Every kilogram sent into space costs fuel, energy, and money. That cost does not scale gently. It rises sharply with distance, payload, and safety requirements. Human missions carry far more mass than robotic ones because humans need protection, air, water, food, and redundancy. This creates a difficult trade-off. The more people you want to support, the more mass you must launch. The more mass you launch, the harder and more expensive every mission becomes. Space does not reward growth. It penalizes it. Time adds another layer of difficulty. Missions last months or years. Hardware must survive radiation, temperature cycling, and mechanical stress without the option of replacement parts arriving quickly. On Earth, infrastructure failures are solved by specialization and scale. In space, crews must handle problems themselves with limited tools and limited time. That pressure grows as missions become longer and more distant. Even optimistic plans often assume continuous progress and funding over decades. History shows that space programs are vulnerable to political shifts, economic downturns, and changing priorities. Long timelines increase uncertainty. Living in space would require not just technology, but sustained global commitment. That commitment would need to last generations, not election cycles. Space does not wait patiently for budgets to recover. This is why many ambitious visions quietly depend on assumptions that are not guaranteed. Stable funding, continuous launches, perfect coordination. None of these are physical laws. They are human choices. When those choices change, space systems do not adapt gracefully. They degrade. A delay in resupply can force difficult decisions. A canceled launch can reshape an entire mission plan. This fragility is not hypothetical. It has already shaped real missions. Schedules slip. Components age. Designs are simplified to survive uncertainty. The farther humans go, the more they must carry everything with them. Tools, spare parts, medical supplies, and contingencies all add mass and complexity. There is no external environment to borrow from. This is why robotic missions often outperform human ones in deep space. They require less support, less mass, and less long-term commitment. They align better with the realities of distance and time. Human presence changes the equation completely. Every decision must account for safety, health, and return. Exploration becomes slower, heavier, and more constrained. None of this means humans should stop exploring space. It means that living there permanently is not just a technical challenge. It is a logistical and economic one that grows harder the longer the timeline becomes. Space does not only test engineering, it tests patience, planning, and consistency over time. And those are limits no technology can simply bypass. Even after hearing all the limits, the costs, and the risks, people still return to the same question. If living in space is this hard, why does the idea refuse to go away? Why does every generation imagine that it will finally be the one that makes space feel like home? Part of the answer lies in history. For most of human existence, survival meant moving. When land became crowded or resources scarce, people migrated. Expansion solved problems before those problems were fully understood. That pattern is deeply embedded in human thinking. When we face difficulty, we look outward for space rather than inward for balance. Space becomes the ultimate version of that instinct, even though the environment works very differently. Science fiction reinforces this idea. Stories rarely show the full cost of living in space. They focus on freedom, discovery, and possibility. Maintenance, fatigue, and slow biological decline rarely drive the plot. Plait has often pointed out that fiction is not the enemy of science, but it becomes a problem when stories quietly replace understanding. When imagination fills in gaps where physics should speak, expectations drift away from reality. Another reason the dream persists is emotional, not technical. Space represents hope. It feels like a future that is clean, organized, and purposeful compared to the messy problems on Earth. That contrast is powerful. Earth feels complicated because it is alive. Space feels simple because it is empty. But emptiness is not kindness. It is indifference. People also underestimate how much modern life depends on invisible support. On Earth, systems hide their complexity. Space removes that illusion. Everything is exposed and nothing is free. The dream of living in space often avoids this exposure. It focuses on destinations rather than processes, on arrival rather than maintenance, on vision rather than endurance. There is also a cultural element. Space exploration is one of the few areas where humanity acts as a single species, at least symbolically. That unity is attractive in a divided world. But symbolic unity does not remove physical limits. Physics does not respond to motivation, and biology does not change because an idea feels inspiring. This creates a tension between hope and honesty. Hope pushes people to imagine space as a solution. Honesty forces them to confront that space, magnifies problems rather than solves them. The dream survives because it is flexible. When one vision fails, another takes its place. If Mars is too hard, people imagine space habitats. If habitats seem fragile, They imagine new technologies. Each version delays the confrontation with the same underlying truth. Living in space is not just difficult. It requires redefining what living means. Space offers purpose and perspective, but not comfort. It offers challenge, not relief. The dream persists because humans are drawn to challenge, even when the cost is high. Understanding why the dream returns is important. It explains why optimism alone cannot guide planning. Dreams inspire action, but reality decides outcomes. When we understand the psychology behind the dream, we can approach space with clearer goals. Exploration instead of escape. Knowledge instead of replacement. When all the excitement fades and the technical details are laid out clearly, space leaves us with an uncomfortable but important question. If living there is so difficult, what does that actually say about humanity's future, beyond slogans and optimistic timelines? It suggests that the future is not about replacing Earth, but about understanding limits more clearly. Space does not offer a clean reset or a second chance. It offers a comparison that makes our situation on Earth easier to evaluate honestly. For the first time in history, humans can see their planet from the outside and measure exactly what keeps it alive. A thin atmosphere, a stable climate range, a magnetic field, and gravity working together over immense time. Space shows us how narrow that balance really is. Outside it, life becomes fragile very quickly. Not philosophically fragile, but physically fragile, dependent on machines, planning, and constant correction. This perspective changes how progress should be defined. Progress is not how far humans can move away from Earth. It is how well we can preserve the conditions that allow complex life to function naturally. Many scientists argue that the most realistic future involves humans visiting space regularly but briefly. Research missions, exploration, observation, and return. Space as a workplace, not a home. That idea may sound less dramatic than permanent colonies, but it aligns better with what biology and physics allow. It accepts that humans perform best when supported by an environment that evolved alongside them. Space exploration still matters deeply in this model. Studying other planets helps us understand climate, geology, and long-term change. Observing the universe helps us understand where our planet fits into a much larger story. What changes is the narrative. Space stops being a promise of escape and becomes a tool for clarity, a way to test assumptions and reveal how rare and valuable Earth-like conditions really are. This honesty does not reduce ambition. It redirects it. Instead of building fantasies that fight physics, it encourages solutions that respect reality and focus effort where it has the greatest impact. The idea that humanity must spread outward to survive often ignores how survival actually works. Survival depends on stability, cooperation, and long-term care, not just expansion into harsher environments. Space makes this visible by removing all background support. When nothing is free, priorities become clearer. Protection matters more than speed. Maintenance matters more than novelty. In that sense, space is less a destination and more a mirror. It reflects our strengths, but also our dependencies. It shows what we carry with us and what we cannot leave behind. Understanding this helps avoid future disappointment. It prevents grand plans from collapsing under unrealistic expectations. It replaces vague optimism with informed choice. Living in space is harder than we admit, because admitting it forces a deeper realization. Our future is not guaranteed by movement alone. It depends on how well we understand and protect the conditions that allow life to exist at all. Another reason living in space is harder than we admit is that humans tend to underestimate how much uncertainty they can tolerate. On Earth, uncertainty is softened by familiarity. Even when things go wrong, we understand the environment well enough to predict how problems usually unfold. In space, uncertainty behaves differently. Systems are complex, tightly coupled, and exposed to conditions that amplify small unknowns. A minor anomaly does not stay minor for long, because there is no natural environment to slow it down or absorb its effects. This forces space missions to be extremely conservative. Procedures are strict. Changes are slow. Creativity is carefully controlled. These constraints are not about fear, but about survival in an environment that does not tolerate improvisation well. Plait has often explained that spaceflight succeeds not because humans are bold, but because they are cautious. Every successful mission is built on layers of restraint rather than risk-taking. That mindset clashes with how people imagine exploration. Popular stories celebrate bold leaps and decisive moments. Real space missions depend on patience, repetition, and restraint. Days are filled with checks, confirmations, and routine tasks designed to prevent small issues from growing. Living long-term under those conditions changes how time feels. Progress slows. Innovation becomes incremental. The excitement that drives early exploration gives way to discipline and process. On Earth, discipline usually serves growth. In space, discipline serves stability. That shift affects motivation. People are not pushing toward new opportunities, they are holding systems together. Another overlooked factor is knowledge decay. Technology does not exist independently of people who understand it. Long-term space living would require continuous training, documentation, and skill transfer under isolation. On Earth, expertise spreads naturally through large populations. In space, expertise is limited to whoever is present. Losing a key skill or specialist has far greater impact in a small, isolated group. This makes space communities more fragile than they appear. Stability depends not just on machines, but on human memory, training, and cooperation over time. Equipment also ages differently in space. Radiation slowly degrades materials. Temperature cycling stresses components. Lubricants behave unpredictably. These effects accumulate even when systems appear to function normally. Maintenance becomes a constant race against time. Fixing one problem often reveals another waiting behind it. The environment never gives systems a chance to rest or reset. This is why long-term visions often underestimate operational fatigue. Not dramatic emergencies, but endless small tasks that demand attention day after day. Living in space requires accepting that effort never tapers off. There is no phase where things simply work on their own. Stability is not achieved once. It must be recreated continuously. This constant demand reshapes priorities. Exploration slows. Expansion pauses. Preservation becomes the dominant concern, even in the absence of obvious danger. None of this makes space exploration meaningless. It makes it precise. It defines where humans can operate effectively and where expectations must be scaled back. Living in space is harder than we admit because we tend to imagine progress as forward motion. When in space, progress often means holding ground against forces that never stop pushing back. Another layer that makes living in space harder than we admit is responsibility. On Earth, responsibility for risk is spread across systems, institutions, and society as a whole. In space, responsibility becomes immediate, personal, and impossible to fully separate from individual lives. Every decision in space carries weight because the margin for error is small. Choosing a design, approving a shortcut, delaying a repair, or extending a mission all come with consequences that cannot be shifted onto the environment or corrected later with ease. Plait has often emphasized that spaceflight forces uncomfortable honesty. When something goes wrong, there is no abstract blame. Physics responds directly, and the outcome reflects the quality of preparation and judgment that came before. This creates a moral pressure that is rarely discussed openly. Sending people into space is not just a technical choice. It is a decision to accept known risks on behalf of specific individuals, not theoretical future populations. On Earth, risk is often invisible or delayed. In space, risk is immediate and continuous. Astronauts are aware that survival depends on thousands of decisions made by people they may never meet, months or years before a mission begins. This awareness changes how missions are planned. Engineers and scientists do not optimize for speed or spectacle. They optimize for reliability, even when that slows progress or limits ambition. Living long-term in space would magnify this burden. Decisions would not affect a crew temporarily, but entire lives over extended periods. Mistakes would not end with a mission. They would shape health, safety, and outcomes for years. This raises difficult questions about consent and expectation. Astronauts volunteer knowing risks exist, but long-term space living would involve people born into those risks without choosing them. On Earth, children inherit environments that are imperfect but fundamentally life-supporting. In space, children would inherit environments that are only conditionally survivable, dependent on constant technical success. That difference matters ethically. It changes how responsibility is distributed across generations. Space does not allow mistakes to be localized in time. Consequences persist and compound. Risk management in space also has no natural ceiling. More safety always requires more mass, more systems, and more complexity. There is no point where risk reaches zero, only points where it becomes acceptable for a specific duration. This is why space agencies define missions carefully. Duration, distance, and objectives are constrained to keep risk within known bounds. Permanent living stretches those bounds beyond what has been tested. On Earth, societies evolve by absorbing risk through scale and diversity. In space, small populations amplify risk. A single failure can affect everyone, and recovery options are limited. Living in space would require not only advanced technology, but advanced social agreements about acceptable risk. These agreements would need to hold under stress, isolation, and uncertainty. The difficulty is not that humans cannot make such agreements. It is that space enforces them continuously, without pause or forgiveness. This constant ethical pressure adds to the physical and psychological challenges already present. Life becomes not just survival and maintenance, but ongoing responsibility under conditions where mistakes are costly. Understanding this layer changes how space living should be discussed. It is not just a matter of engineering feasibility. It is a question of how much risk society is willing to embed into everyday life. Living in space is harder than we admit because it demands responsibility that never switches off, and consequences that cannot be deferred or shared with a forgiving environment. When people imagine the first generations of humans living in space, they often picture explorers. Curious, bold individuals pushing outward, discovering new places, and expanding human presence. In reality, the first long-term residents of space would live very different lives, shaped more by preservation than exploration. In space, exploration is the exception, not the routine. Most days would not involve discovery or adventure. They would involve inspection, maintenance, monitoring, and repair. The priority would not be moving forward, but keeping everything from slipping backward. This is a major shift in identity. On Earth, growth usually comes from change and expansion. In space, growth would come from stability. Progress would be measured by how long systems continue working without failure. Plait has often noted that spaceflight rewards patience far more than heroics. The people who succeed are not those who take risks, but those who avoid them quietly and consistently over long periods. Living in space would turn humans into caretakers of machines and processes. Daily life would revolve around checking readings, listening for irregular sounds, and responding to small deviations before they become serious problems. This changes how work feels. Instead of pursuing new goals, most effort goes into protecting existing ones. Creativity still matters, but it is applied to maintenance rather than expansion. On Earth, maintenance is often invisible and undervalued because the environment supports it naturally. In space, maintenance becomes the center of life because the environment provides no support at all. This also changes social structure. Communities would value reliability over novelty, caution over speed, and consistency over experimentation. These values are practical, but they feel very different from traditional ideas of exploration. The people best suited to this life might not look like the explorers we celebrate in stories. They would need to tolerate repetition, responsibility, and long periods without visible progress. This does not mean such a life would be empty. It would have purpose and meaning. But that meaning would come from protection rather than discovery. Keeping everyone alive would be the achievement. The challenge is that this reality clashes with popular expectations. Space is often sold as a place of freedom and possibility. In practice, it demands discipline and restraint. Over time, this mismatch could create disappointment. People might arrive expecting adventure and find instead a life defined by procedures and limits. This gap between expectation and reality is dangerous. When people are unprepared for the true nature of space living, motivation can erode and small stresses become larger. On Earth, dissatisfaction can often be relieved by changing jobs, locations, or lifestyles. In space, options are limited. Dissatisfaction must be managed internally or through social structure. This is another reason why long-term space living is harder than we admit. It requires not only technology and planning, but a deep cultural shift in how people define success and fulfillment. Exploration has always been about movement. Living in space would be about stillness, vigilance, and care under constant constraint. The first generations of space residents would not be pioneers in the traditional sense. They would be stewards, holding fragile systems together so that life could continue at all. That role is essential. But it is very different from the dream that often draws people towards space in the first place. Understanding this difference is crucial if we want honest conversations about the future beyond Earth. One of the most persistent mistakes people make when thinking about space is comparing it to frontiers on Earth. Oceans, deserts, polar regions, or distant continents are often used as analogies to explain why humans will eventually settle space as well. This comparison feels intuitive, but it breaks down almost immediately under closer examination. Every frontier on Earth, no matter how hostile, exists inside a planet that supports life. Gravity works normally. Air is present. Water can be found. Even in the most extreme environments, the basic rules of biology are still being met by the planet itself. Space does not work that way. There is no underlying system quietly helping humans survive. Outside a spacecraft or habitat, the environment is instantly lethal. This is not a harsher version of Earth. It is a fundamentally different condition. When humans crossed oceans, they could fail and still survive. A shipwreck did not guarantee death if land was nearby. On Earth, danger often comes in degrees. In space, danger is binary. Protection works, or it does not. Plait has often pointed out that space is not a place you gradually adapt to through exposure. Exposure is what kills you. Survival depends entirely on remaining sealed inside artificial systems that never stop functioning. Frontiers on Earth allowed learning through trial and error. Mistakes were costly, but they were also survivable. Space does not allow that kind of learning. Errors must be anticipated and prevented before they occur. This difference changes how progress happens. On Earth, exploration often accelerates as experience grows. In space, experience does not reduce danger. It only improves preparation and response. Another problem with the frontier comparison is that Earth frontiers eventually became self-sustaining. Agriculture, trade, and local resources reduced dependence on distant support. Space offers no equivalent path. Local resources in space are difficult to access, process, and use reliably. Even when materials exist, turning them into breathable air, water, or food requires complex infrastructure that must already be in place. This creates a loop that Earth frontiers never faced. To use space resources, you must first bring a fully functioning life support system from Earth. The frontier does not support you while you build it. On Earth, the environment often rewarded risk-taking with opportunity. In space, risk-taking is punished more often than it is rewarded. Caution, not boldness, determines survival. This is why space exploration has always advanced slowly and deliberately. Progress comes from precision, not momentum. Every step is measured because the cost of misjudgment is high. The frontier metaphor also encourages the idea that space settlement is inevitable. History shows that some frontiers are abandoned when costs outweigh benefits. Space may fall into that category for permanent living. None of this diminishes the value of space exploration. It clarifies its nature. Space is not the next chapter of human expansion in the traditional sense. It is a separate category of challenge altogether. When we stop comparing space to Earth frontiers, expectations change. The focus shifts from settlement to access, from ownership to understanding, and from growth to insight. Living in space is harder than we admit, partly because we keep using the wrong mental models. We imagine history repeating itself, when in reality, space demands a new way of thinking entirely. The sooner that shift happens, the more realistic and sustainable space exploration becomes. Another idea that quietly shapes how people think about space is the belief that future generations will solve what we cannot. That even if living in space is hard now, time itself will smooth the problems away. This belief is comforting, but it often replaces planning with hope. History shows that time does not solve problems on its own. People solve problems, and only when conditions allow it. In space, many of the hardest limits are not technological gaps, but physical boundaries that time does not soften. Radiation will not become less damaging because humans are more experienced. Low gravity will not suddenly stop affecting bones and organs because people have lived with it longer. These are not early-stage problems waiting for maturity. Plait has often stressed that science progresses by understanding limits, not wishing past them. Some problems become easier with better tools. Others remain stubborn because they are rooted in how nature works. The idea that children born in space would naturally adapt better also sounds appealing, but it rests on unknowns, not evidence. Development happens under specific conditions, and changing those conditions introduces risks we do not yet understand. On Earth, generations inherit environments that support life by default. In space, future generations would inherit environments that require constant technical success just to remain survivable. That creates a fragile dependency across time. Each generation would rely on the previous one not only for culture and knowledge, but for uninterrupted system integrity. If something fails, the consequences would not be abstract or distant. They would be immediate and personal, affecting people who had no choice in the conditions they were born into. This is very different from technological inheritance on Earth. Here, infrastructure can degrade and be rebuilt gradually. In space, degradation without replacement quickly becomes dangerous. Hope in future solutions also ignores how complex systems age. The longer a system exists, the more maintenance it requires. Complexity does not decay gracefully. Future generations would not start fresh. They would inherit systems already worn by radiation, stress, and use. Maintaining stability would likely become harder, not easier. This does not mean progress is impossible. It means progress is constrained. Each improvement trades one problem for another, often shifting burden rather than removing it. The danger of assuming the future will fix everything is that it delays honest decisions in the present. Planning becomes optimistic instead of realistic. Space exploration benefits from humility. Accepting that some limits persist forces better choices about where effort is spent and what goals make sense. Future humans may understand space better than we do. But understanding does not equal immunity. Physics does not negotiate across generations. Living in space will not become easy simply because time passes. If it becomes easier at all, it will be because humans choose carefully where to push and where to stop. Recognizing this is not defeatist. It is what allows ambition to align with reality instead of colliding with it. Even the most optimistic plans for long-term life in space share one hidden requirement that is rarely discussed openly. They all depend on restriction. Not freedom, not openness, but carefully enforced limits on behavior, movement, and choice. On Earth, freedom feels natural because the environment absorbs many of its consequences. People can take risks, make mistakes, and change directions without threatening the basic conditions of survival. Space does not allow that kind of flexibility. In space, every action interacts with a fragile system. Using more water, producing more waste, or changing schedules affects shared resources immediately. Freedom without coordination quickly turns into instability. Plait has often pointed out that space habitats are closer to life support machines than living ecosystems. Machines require rules. They function best when inputs are predictable and controlled, not when individuals act independently. This means long-term space living would require strict regulations on daily life. Resource use would be monitored. Activities would be scheduled. Personal choices would be limited by system capacity. Such limits are not signs of authoritarian control. They are responses to physical reality. Space does not allow personal freedom to override shared survival needs. Even movement would be constrained. Habitats would be designed to minimize wear, reduce risk, and control airflow and contamination. Wandering freely would not be practical or safe. On Earth, people associate progress with expanding options. In space, progress would often mean narrowing them. Fewer variables make systems more stable, and stability is the highest priority. This creates a psychological shift. Life becomes less about exploration and more about compliance with systems that must function continuously. Meaning would come from contribution, not individual expression. Some people would thrive under these conditions. Others would struggle. Space living would select for specific personalities, not universal human traits. This challenges popular images of space as a place of ultimate freedom. In reality, it would be one of the most regulated environments humans have ever created. The irony is that these restrictions are what make survival possible. Without them, systems would drift, conflicts would escalate, and margins would disappear. On Earth, limits are often invisible because nature enforces them quietly. In space, limits must be enforced consciously and continuously by people. Optimistic scenarios sometimes assume these constraints will feel temporary. But in space, they are permanent. The environment does not soften with familiarity. Over time, living under constant regulation changes culture. Values shift toward reliability, predictability, and caution. Creativity is expressed within narrow boundaries. This does not mean space living would be miserable. It could be meaningful and purposeful, but it would not resemble the open-ended freedom often imagined. Recognizing this helps separate realistic planning from comforting fantasy. It forces us to ask not just whether humans can live in space, but how that life would actually feel. Living in space is harder than we admit, because it requires trading freedom for stability in ways most people never fully imagine when they dream about the future. After everything we have seen, one truth becomes difficult to ignore. Earth keeps winning every comparison, not because it is perfect, but because it quietly does things no technology can fully replace. Air, gravity, protection, recovery, and balance all exist here without constant supervision. When humans leave Earth, they do not step into a new home. They step into an environment that must be fought at every moment. Survival depends on machines, planning, discipline, and attention that can never relax for long. That alone sets a hard limit on what living can realistically mean. Space does not reject humans out of hostility. It rejects assumptions. It strips away the background support we take for granted and exposes how dependent life really is on specific conditions. That exposure feels uncomfortable because it removes comforting illusions. Throughout history, progress has often been imagined as movement outward. New lands, new frontiers, new worlds. Space challenges that idea by showing that movement alone does not create safety, stability, or sustainability. What space really teaches is contrast. It shows us what life looks like without forgiveness, without margins, without recovery built into the environment. And through that contrast, it quietly explains why Earth has mattered all along. This does not make space exploration pointless. It gives it purpose. Space is where we test ideas honestly, without nature cushioning our mistakes. It is where physics answers clearly, without compromise or emotion. Living in space is harder than we admit because admitting it forces a shift in values. It asks us to replace fantasy with responsibility and spectacle with understanding. That shift is uncomfortable, but necessary. The future of humanity is not defined by how far we escape Earth, but by how well we understand what makes Earth work. Space exploration helps us see that clearly by removing everything that makes life easy. Earth is not weak because it needs protection. It is rare because it provides support. Space makes that difference obvious by offering none of it freely. When we stop expecting space to become home, we can finally appreciate it for what it truly is. A place of learning, perspective, and humility, not comfort or refuge. The universe is vast, but it is not generous. Life survives only where conditions align, and Earth remains one of the few places where that alignment holds naturally. Understanding this does not limit humanity's future. It grounds it. It replaces endless expansion with informed choice and replaces illusion with clarity.